right, so let's do a quick example. If I'm given 2 points, P and Q, so we start at P and we end at Q, let's find the component form of the vector that represents that directed line segment, and let's find the magnitude. So if you remember, the component form of a vector is simply the difference from the terminal, from the initial point to the terminal point, and in each dimension. So we want to find the distance it traveled by going from Q to P. So then we would say that the first component, V1, is the terminal point minus the initial point in the first component there, so the x component, which is -1 minus 1, which is -2. The second component is the same idea in the y direction. And so that's going to be 2 minus -1, which is +3. Now, if you're having issues doing this, for some reason that's a little confusing and you want a little more intuition about whether or not you've done this right, feel free to graph it, right? You could always graph so 1, -1 is here, and -1, 2 is here. And we see that we've gone, so that's P and that's Q. We've gone -2 in the x direction and +3 in the y direction. So checks out. Therefore, so the vector, remember, is just those individual components. So our answer is -2, 3. That is our vector. So let's find the magnitude. So if we want to deal with the magnitude here, remember that the magnitude is the sum of the squares of the components, all under a square root. So our magnitude is the square root of 13. And so magnitudes are not always clean. They're going to be ugly. I mean, you've dealt with this kind of stuff before. So just kind of be aware. So as we come up, we're going to actually discuss how we can start thinking about unit vectors with relation to the magnitude.